Going live. I think YouTube is live. I think. Yeah, YouTube is showing your screen.
Cool. All right. So, folks, we are back. Go Singapore is back and it's online because COVID-19. So, thanks to Engineers.SG and Hackerspace who have helped make this happen. Otherwise, we would be offline and not happening. Yeah. If you wish to speak at Go Singapore in the next meetups, please submit your proposal through. And now I will pass my time to Sudarshan, who is the first speaker for our March meetup. Cool. So I pass to you.
We just share my screen.
Yep. Can you go with that? Something. Yes.
Oh, hey. So,
All right, can you see my screen now?
Okay.
Oh, wait, hold on. All right. To go?
Yep.
All right. Sorry, it took us a bit. We're trying to get this thing set up, and all right. So basically, what I'm going to be talking about today is something that we did recently at Zalora, and something that made our life slightly easier. And we basically want to share how we did that in our journey and reasoning with you guys, right? So basically, this is like the title says, code generation in Go, and how we sort of automated some of our things to make it really cool. So one of the nice things about Perl, I think, is this quote by Larry Wall, the creator. He says, "Gamers need to be lazy." So I think my colleagues and I are a bit lazy. We were tired of doing the same thing over and over again, and decided we'd automate it and try and a little bit of code generation. So this is one of my favorite slides. It's yeah, we can do it, but we also need to tell you why we want to do it, right? Right. So basically, the story starts with microservices. We all know it's awesome. This site is deliberately empty. It's because most of us know why we like microservices. They're very scalable. You can work on independent microservices, independent of each other. You can scale out devices independently as well, right? So they are awesome. And the way we structure our microservices is they are reusable by multiple services downstream, which led us to what to think this. So basically, the pluggable code for the microservices is abstracted away into SDKs downstream services can use. Why did we do this? Because one, they're reusable. Downstream services can just import the SDK as a dependency. Call these functions over and over again. It makes sense. All our SDKs live in one monorepo. And because they're homogeneous and live in a monorepo, it's like very easy to make modifications and distribute these modifications. Another feature that abstracting away into SDKs is we use protobufs a lot. And because we use SDKs, essentially this protobuf code is abstracted away from the client itself into the dependency. So it's awesome, right? So we've got microservices, we've got SDKs, and we got this. So this was the bit of a jumble that we entered into. So basically, we had a lot of microservices, and then now we had a lot of SDKs because obviously these microservices were talking to each other, and we could Okay. So what happened was, you see, it's maintenance hell, right? So we've got 3 to 4 developers, and we really have to keep updating our SDK all the time. Anytime we added a new feature, a new endpoint, we had to update our SDKs. Anytime we added a new query parameter, we should ideally update our SDKs. And God forbid, imagine we change something. Obviously, we're trying not to be backwards and compatible, but if we change something, then we needed to update our SDK. So this led to a lot of copy pasting. Every time we had to, really endpoint, we'd have to copy the old and change a very few things, and and then go for a release. So this is basically a lot of repetitive work and a lot of frustration. And also when you copy paste things, you could essentially forget something, and that could end up being disastrous for maintenance as well. Before we go further on how we did it, let's talk about a few pros and cons of code generation. I think these are general industry observations on how code generation is, and but this is a very opinionated list, right? So feel free to disagree or think differently. Right. So the good parts of code generation, basically why we want, right? So we don't really have to worry about the boilerplate code. We don't have to constantly keep rewriting the same code that we already know. It's boring, right? And we're lazy, and therefore we want to automate it. It also makes our turnaround time fast because we don't have to do this manual work. It's all about just adding the one particular point that triggers this generation, and then your build systems would take care of it. You could integrate Bazel to it. You could have a make file that runs this. You could put it on a CI/CD pipeline and have it automatically generate based on certain changes, right? So it's very fast. Those are the nice parts of it. The bad parts, you could essentially have code duplication. You've seen these some of these old C+ generated files, you notice a lot of repetition. There's a lot of mapping and remapping. Some of the thrift files come to mind. So if you've used thrift, then you notice that generated thrift code is sometimes really, really incredibly interestingly hard to read. So that's the second point. So generate necessarily isn't always easy. A bunch of bytecode baked in. It's hard to follow, and if you really want to use this generated code, or if you expect someone is going to be reading this generated code, then code generation could essentially be a hassle, right? And we absolutely expected people to generated code, because the generated code, I'll show you in a bit on what we intended to generate. So this was important to us. We couldn't have code that go to read or change, right? And also, I think in generated cases, one difficulty is really telling apart what is generated and what is not generated. So if you want to make changes, you want to really be able to tell which part of code is generated and which part isn't. This is not a problem for Go. Again, I'll show you why. But it used to be a big problem for C++ and Clojure generated codes. Right. So the really, really bad parts about code generation is generation is like stamping a Band-Aid into a wound, into a bout, and then assuming you have it's just a flesh wound. And basically what you're going to do is you're going to think that your code is okay, and you're going to be fine ignoring it forever because generation is taking care of it. So if you have a complex code that generation automates, then it's basically automating the complexity away. So you're generating this away from your application, and you absolutely don't want it, right? So if you think about, or if you look at the slide, you can see it's very obvious that the bad and ugly really weigh the good. So why did we go ahead and do it anyway, right? So for that, I think it's important to show you how a project is structured. Oops. Right. So this is like a skeletal outline of how we structured our SDK. So the client itself is a package. It's basically, the Go HTTP client abstracted out with, wrappers on top of do and request. The reasoning here is that we wanted to bake in authorization and retrying logic into it. So the client itself is an abstracted mini client that is sufficiently self-existing. API.go is basically the specification. It's a set of interfaces where you look at the AWS SDK, and they give you a bunch of functions that you can use if you use the constructor to really construct an object. And API.go is just a bunch of specifications to do that. Methods.go basically where the definition of these specifications go. So in C++ speak, API.go is sort of a .h, and .go is sort of a .c, pp, or .c. So, but regardless, so the API.go is a set of definitions, and methods.go is implementations, and that's where we're going to be doing our generation. The methods.go is going to be the place where we generate code, and structure is basically serves as a demonstration on why we think only the positives apply for us and the negatives don't. I'll get to the code duplication in a bit, but we're not essentially abstracting any complicated piece of logic out. What we're abstracting is this. So if you look at the comment is basically the endpoint. The code itself is how we abstract the endpoint away. So if I have to give you a brief run through, you just create an operation struct, and then you use that to call a new request. And there's a bit of a bug here. This should be nil comma error, and then you just call a request send. And if it passes, then you just return the details that your struct that was already defined, right? So think about it. The most important there is an example of a different endpoint. Look at these two. You can see that the only things that stay the same are these two, right? And everything else is basically configuration. So you need to essentially write this, or write what the inputs are and what the outputs are, right? And the outputs go here as a response. If there were any inputs, they would be processed. Most of my examples are get. So in this case, they're not present here. And that's basically why we wanted to automate it. If you notice, it's very easy to read. As a matter of fact, the code that you're looking at was actually generated. Therefore, it doesn't look very hard to read at all, because it's very simple. It does a specific thing. It basically is like, go to an endpoint, do this, and get this back and send it back, right? And that leads us to a situation. Code generation, the way we were intending to do that was simply like building a little compiler. And we were doing this on steroids simply because Go provided us all the tools that we needed, right? So maybe a primer is how compilers work. They're broken down into 3 steps, right? You've got the parsing, where you essentially read code that's already written, right? And then you have a transformation where you change the code into a format that essentially is that's essentially easy to write from, right? And then you finally have the code generation, which is mostly what compilers do, is they optimize part and into binary so that your computer understands it. In our scenario, in our case, this would be to just write more Go code, right? So parsing, you can split it as lexical and syntactic analysis. So lexical analysis is basically reading through the code and creating tokens, right? So it knows the keywords, it knows the primitives, it knows the values you assign to primitives, and it creates a list of tokens on all these values. Syntactic analysis, interestingly, is a sort of transformation. So basically, syntactic analysis is the part where you convert all these tokens into an abstract syntax tree. So when Go is basically compiling your code, what it does is first there's a lexer running, right? So the lexer basically tokenizes all of your code, and then it builds an abstract syntax tree, right? And this abstract syntax tree essentially is a representation of your code, right? And then there's transformation. So transformation, reason it exists is because okay, this is not necessarily relevant to us, but we'll still be doing it. Transformation exists, intermediate representation exists beyond an ESD, is so that you swap in front ends and back ends from your compilers. So modern compilers like LLV could essentially, swap out a C front end, back end for GCC, and intermediate representation allows you to do this. And we took advantage of this style of how the compiler works as well. That's the reason why I'm running you through it. And finally, code generation is using this representation to arrive at your desired output, right? So there's an input, there's a process, and there's an output, right? So that's essentially how we designed our generator to look like. So the generator was made up of a reader and a writer, right? So the reader would essentially do the parsing part of it, and the writer would do the code generation part of it. But where is the representation, you may ask? And that is basically this array. So the API struct is our version of an intermediate representation of this of what we're reading, right? So essentially, if you look at this definition, you'll notice that all the values we need to really generate these, right? We know what endpoint to call. We know what method it has to be. If it's it's just the name. We know what path to call. The path and endpoint together would give you the final URL. We know what HTTP to use. So we need to know it's a get or a put. In case of a put or a post, you need a body. And then we need to know input parameters and output parameters the method needs, right? So essentially, this is, in our scenario, an exhaustive list of what we needed to really generate the final, right? And now that we know the working pieces, we wanted to see how we wanted to build each of these independent pieces. So we needed somewhere to read from. We know what to write already. We know that we're going to write into a .go. Basically what we want to write to, right? So we need to know what to read from. We already know the intermediate representation as well. Steps are read from somewhere, put it into an intermediate representation, and write to somewhere. Why we have an intermediate representation is because we want to offer the liberty of changing the writer if someone else wants to modify it. What if someone wants to generate the output as a .c to make, this would still allow it to do it. The way this thing would allow you to do it, right? Okay, so let's talk about the reader. So where could we essentially define the way the application is structured, and where could we essentially read from? And we have multiple options. One is Swagger. We could essentially read from a Swagger specification and then generate a code. The slide itself is very opinionated. I'm not very fond of Swagger. I've found it very loopy, difficult to write. So we almost immediately dismissed it as an option. Could it be a JSON? This looks nice, right? So if you wanted to maybe create these two functions, then all you had to do was to define input parameters where the structure of the output parameters, the structure of the outmeters, and you could essentially tell what endpoint and provide all the details. This could work. This looks nice, right? But there's the third option as well. You could also just define Go interfaces to do this, right? So remember our API.go. So if you could define it by hand, and if you notice, these two have the same details, right? So it's just a different way of representing it. So essentially, to represent the same thing, that's a JSON, but you can represent it in Go itself, right? So what we could do is, define an interface and then represent the functions and the inputs and outputs in the interface, right? And then, obviously the one downside of doing this is to annotate certain values. Like, for example, there's no way of representing point in these functions, right? So that becomes a comment, and then you annotate this function to do that, right? And yeah, so that's basically, these are the three options, right? And specifically decided to go with option number 3. I'll tell you why. So basically, this is a Go code base, right? So we wanted to keep all the changes internally to Go. We didn't want to. So we knew that the developer maintaining this code base essentially would have to know Go already, right? They're going to be reading these methods. There's other parts of components of this code that is Go, right? So why not have all of it in Go? We did not want to rely on a derivative syntax, because how JSON seems to be, it essentially turns into something like HCL for Terraform, where you declarative syntax, and then it gets transferred into something that's entirely different. And we have to write the interfaces anyway. So it made sense for us to rather write the interfaces by hand than generate them from JSONs, right? So that was the reasoning. And we decided, we just take the interfaces simply because we wanted to keep everything Go. So I know everyone probably knows JSON, but essentially they don't necessarily have to know the structure of this JSON. They don't necessarily have to know what the schema is that they have to adhere to. And that is something that we didn't want to be on the cognitive level, and therefore decided to go with what we think simpler approach, right? So that's why we decided we'd go with interfaces. So because we go with interfaces, we had an interesting problem to solve, right? So imagine we used JSON, right? So the thing is, we could have solved it with a simple parse, right? So you could just, unmarshal the JSON and then arrive at the intermediate representation that we had. Unfortunately for us, we decided to go with parsing the, right? And because of this, we needed to look, we had two ways to do it. One was, read it line by line using a buffer, right? And then interpret every line and, use a preconceived opinion on how a function should be defined to actually arrive at the values that our intermediate representation needed. But you see the problem with this, as I say it, right? It sounds so painful, it sounds so opinionated, and it's so not real at all. So a more robust way of doing it was the AST to parse. So Go has really, really cool tools that let you do this very, very easily. So it was just a matter for us to import Go AST, Go parser, and Go token to do this. Go parser basically parses it already into an AST. And once you get you can just give it a reader or the name, and it would pass it into an AST. And once you have the AST, you could essentially, loop through it. So Go gives you the tools to walk through, to run through the AST. And then, you can essentially pick out for interfaces, or, pick out methods and then pick out their parameters. And that's very interesting. And using that, you can build this intermediate representation. So now this was the way we, leveraged AE to build our reader and arrived at the intermediate representation. And finally, the final parts of the code were basically the easier parts. You just had to convert this representation into a final .go, right? Into to do this, right? And where we wanted to arrive at. And basically, initially, it was a lot of format writes or string replaces on a file, and that seemed very ugly. It seemed very difficult to follow, because then you had a lot of string replaces, and you're like, where look for where do I look for where I changed a line, right? So we decided Go templates, and this seemed to be a really, really neat solution. Because if you just look at this template, then it's in my opinion, not too difficult to arrive at what it's trying to do. Right? It's declaring a function right here. It's adding all the input parameters, adding all the output parameters, and then if you look at this, it's calling the operation, and then it's basically the same. It's very readable. It's easy on the cognitive load. So we decided we'd use Go templates, and this turned out to be interesting, and it's easy to change, easy to maintain, and could work out really, really good. Yeah, so that's basically the whole end-to-end of how we did it. There's also a little bit of housekeeping in case someone wants to do this. These notes are basically how we decided to do it. Decided to put all the generator code in the internal package. This seemed to be nicer use cases for internal. I'm not the fan of it, but this seemed to be a use case for it. The generator would live inside the internal. We'd obviously expose a command, the generator to run. And the most important thing is to add this directive, this build directive, to the root of your program. So our API.go, if you remember our project structure, would have right under the package declaration. And this is how Go knows to run the generator, right? So if you run Go generate, it would look at the root to see if it's got the directive somewhere, and the directive would redirect it to your actual generator. And that's basically the final pluggable point for us. If you want, there's a blog as well. I have code snippets and there's a bunch of as well on how I loop through the AST. I didn't want to include that today because it seemed a little dry and seemed reasonably easy to understand as well. So if you want more information, it's definitely and that's basically it. If you guys have any questions, I can take them.
Virtual claps, guys. Anyone got questions for Sudarshan? You can on the Zoom chat or
two questions. Two questions now.
Oh, two questions. Yes.
Okay, I'm just gonna see how I
Can you
Turn
check
on your webcam as well?
Oh, okay. Hey guys.
Okay. Okay. Cool.
Sorry, I'm just trying to navigate through this.
Any? So there's two questions. Two questions from Suyin.
Can you read out the question?
All right. So the question that I'm seeing is, how did you pass that access and URL? All right. So let me answer the first question. So basically, the AST parses it. So that's easy as well. If you look through my blog, then you'll see that basically parses it into a struct called docs, and then you can loop through this. So basically, what essentially we did was we looped through the docs and added a regex to extract what looked like a HTTP verb and what looked like a URL from the comment. Yes, a regex could be a performance penalty, and I think my answer, yeah, good old regexp, and my answer to be tied with the second question. What about the performance of template generation? So essentially, performance is definitely, while we wanted to write very clean code, performance was the last thing on our mind. Simply because we'd be generating code during merge time, right? So when it is merged, that's when the generation happens. It's going to happen in runtime or build time. So anyone who uses this library is already going to see generated code. So the templates are not going to be generated on the fly. They're only going to be generated when we add a new change. So it's sort of like if you used Hugo, it's basically like Hugo build or Jekyll cell you deployed for the time. And once you never have to worry about it again until the next build. So the performance of template generation at this point doesn't seem too much of a concern. And it's not, and I can tell you it's not slow in the sense that I've never had to wait. It's as instant as running Go generate and then seeing your methods come out. And that's also the reason why regex didn't seem to be a problem for us here as well. One was it was a simple OR condition, and two is we're probably only going to generate it every time there's a change to the library itself. And but you're right. I think it's something that we could benchmark because essentially what our plan is to make it a monorepo, and essentially it could add up. But that's definitely something we could take into consideration. How about authorization and authentication? Excellent question. So basically, the reason why you don't see any authorization or authentication in this guide or in this presentation is because abstracted away into the client. The way we did it, if I may, is we a separate interface for authorizer and the client, right? So that happens when you do a send request. It's absolutely away from different concern, and you don't necessarily want to be putting it into every method to, to authorize it. So that it ended up being a good decision as well, and therefore it's basically abstracted away into no problem. Does anyone else have any questions?
Anything on YouTube?
I'm just going to see if I missed any question.
Authentication, authorization, you answered that?
Yeah, I answered that.
Just answer. More question. Okay. Give it a minute.
All right. Thanks so much for this, and feel free to hit me up on my GitHub or oops, I think it's a slide. Sorry, I'm just terrible with slides.
Interesting talk. Thanks.
I'm just gonna put it out here so you can get it. So, any more questions, or if you really wanted to do it, feel free to shoot me on these accounts. My Twitter's got like about 20 followers, so don't worry about it. Just feel free. Send me a and should be good. Thanks so much for listening, guys. Do I just or stop sharing?
Yeah, stop. Hey, you see.
Oh yeah, can you push it? Should be. Hello. Sangam,
He's on mute, so.
let me drop you a message.
Okay.
Oh yes. Perfect.
Okay.
So next up we have Sangam. He's literally 1,000 miles away from us. But thanks to COVID-19, this is happening. So without further ado,
He's muted though.
Sangam, are you unmuted?
Hello.
I think you need to oh yes.
Now is yeah.
Awesome.
So
We can hear you now.
yeah. So today's topic for this particular meetup is Docker plus TensorFlow plus Golang.
I don't think you should turn it on.
Yeah, this is audible.
No,
Yep.
Yeah. So my name is Sangam. So I'm a Docker community leader, Bangalore, one of the largest community in the world. We have around 15,000 members. And recently I published book on lightweight Kubernetes. And lightweight Kubernetes, and I started recently a Gopher lab, Docker lab, and Kube labs. I have written around, like, we have a lot of contributors. So I create education content also in free time. Also I run a meetup called Octato Meetup. Octato is a tool for Kubernetes for developer. So you can check it out. This all contents, or let's move forward. So what is a TensorFlow? Just I will give a little bit overview. So TensorFlow is a just project started by Google in 2015. They released it publicly, but in 2017 they have announced first version of TensorFlow for real use. So what is the TensorFlow in general? I will explain. It's just like a simple array of number or a function that transfer according to certain rules under the changes of like using like array. We use array. So in TensorFlow is like open source library which we use a graph based computation, which is like a GPU. It is a graphic process unit. So using that you can use for this data science. You can predict images. You can use for a deep learning or neural network. It has a lot of capability. uh, Google is using for lot of their use, and Google thought it's good for world to uh, share this particular new practices. So Google come up with TensorFlow is the end-to-end open source platform for um, machine learning. It's like fast, and it is a very easy to use in any languages. So I recently used in Python. So I thought like I will start something new, how to use with Go language. It's just a hobby project. So what is the challenging thing for me is that how to I like learn, or how to use this TensorFlow with Go language is the one of the challenge thing. And another challenging thing is that how, if you want to run this application in containerization, how I will create this particular new dependencies which give you me to run this TensorFlow and Go. So this is a bit challenging for me. So you can go this URL, you will get the TensorFlow pre-trained model. So I am using inception model. Inception model is used for the specifically image recognition. So image recognition, it will give a 74 uh, percent prediction, and it has all the pre-trained data set here. You can download and you can use it. That I'm using just pre-trained model. Let's say you can download from this URL also, and you can check this Docker file. I got one Docker file, so I'm using this Docker file for my as a dependencies. So what I did is that I created a simple like URL parameter argument. So it is passing the URL to the particular, it's passing the URL to the particular Docker file. So that is my first challenging thing. So I started with simple program. So I created this simple main.go file, and I created one parameter which where you can paste the your image link, or this is a simple like this. If I build this Docker file, after that when I run, I will pass the link of image. So it will get that image link is input for me. So this is a simple code logic for you can use this for to get the images from URL. So next thing is that in TensorFlow there is a lot of, you are getting a image, you have image, so you need to match this particular thing with your trained model. So you can, so you can you can use something called normalization in TensorFlow. You can create a new sessions, new graph session. It will normalization is a simple thing which is run the sessions to like get you input and match with your particular like whatever image you are passing or your labels. So this is a simple code. After that, next challenging thing is that whatever a tensor is there, so I need to create convert this go value to tensor. So this is a bit challenging. So I have the particular image, I have the data set, data file where already pretend data is there. So I need to take image of 224 into 224. So using that, here you can see that I passed 20 224 to 2024 here. uh, i have I have converted this into the tens. Like I'm just matching the whatever the value I'm getting to the my existing data. So this is a simple logic to create a graph to decode the your whatever your image. So after that, it will initialize the session. It will the run the session. We'll see the full code. This is one is the piece, a little piece of code, so it's easy for you to understand. Next thing is, this is my Docker file. So what I did, I created this like I got this dependency. I'm using these dependencies for running a TensorFlow with Go, and you can download this pre-trained model into your Docker file container. After that, you can specify your working directory, or you can give a entry point where your program is located. So in backend, what's happening is that new TensorFlow is converting from a Go value to Tensor, building a graph of your image, initializing the session, all graph operation in TensorFlow, uh, and it's running a normalization function. And after that, it's transforming that image using ImageNet. ImageNet is one of the library in TensorFlow or machine learning. It's used for images. So yeah, I'm using ImageNet. So this is a like simple example where let's say you can give a Docker run and particular your Docker file, and you can pass a parameter. Let's say I'm passing a parameter as a mouse image, or let's say a Go language logo. So I will show you a demo. So you can go to this particular link if you want to test now. So I'm sharing link here. So this is a link. You can go and start a free session, which is like it will give set up a free Docker machine for you, so you can use that. So I have started the simple machine for, we'll test it out. Okay, so this my instance is running, and this is the code. You can just, if you are running on currently, like you want to practice right now, you can use this code. So I have created a Git repo for my this project. So this file. So you can just clone it, this particular repo from Git repo. So let's say I have this particular Git repo. So let's say I have cloned it. So I'll check. So it's there. So I will get my, so I have one main.go file where my code is there, and I have another file is Docker file. So this is my Docker file. You can jump into this particular directory after that, and after this you'll get this particular, you can build now a particular your Docker file. So I'll build this Docker file. So it will take time. So this is a particular repo for TensorFlow model. So here is my data. So here is a pre-trained data you will get at this text files. So this is a particular data for ImageNet and all the data you will get pre-trained model. I'm using this particular data. So this is data where there is already labels which give you, which is particular. So this is particularly there is a data and labels where which define which data particular prediction for which images. So now my Docker particularly Docker file is built. So now I will just pass my particular image from URL. So I have this particular, so I'm passing this image as a parameter into Docker file. So I will clear my screen. So this is, I will run particular. So you will see this is particular my input file. So it will give a prediction that this particular thing is what is this. So already label is defined in the pre-trained model. So there is a mouse is probability of 14.93. So this is a mouse symbol, I guess. So this is a particular small hobby project I have created. Uh, so let's move forward. So you can run this particular TensorFlow. So I will show you the Golang code now. So this is my Go code where you need to import the particular TensorFlow. Two library you need to import. One is TensorFlow for Go and TensorFlow for OP, which is particularly for operations. So you can create two labels of structure, type of structure, and one is probability and one is as a label. And first you can create particularly to get a URL. After that you can get a normalized particular tensor. So you can create create for whatever model graph you're getting. So you need to load that particular whatever model, existing model in two text files are there. So like this, one is a graph file, one is a label file. So we have a two text file in pre-trained model. So if you go to this, if you downloaded this or you go to this, you'll get one folder called data, where this particular two text file is already pre-trained model is there. So we loading this particular model first, and we are scanning this all the graph files or label files. So after that we are normalizing a particular session, tensor session. After that we are just decoding that whatever image is there to whatever image and whatever our existing data. In this particular example, image need to be a size of 224 into 224. after that we are containerizing this particular application, overall application, and after that you can run it and pass it uh, any image of 224 into 224. After that it will give a probability and what are the label detection. So we got a detection of the label is mouse. So I passed this image as a particular uh, parameter. So I get a prediction of mouse. I think we got output. So next, so that's it. So I have created this Gopher lab. I have 200 tutorials. You can go and uh, you can use these particular resources for learning, or you can join using Slack. I have a Slack community of around 3,000 people where we share around Docker, Kubernetes, most of CNCA project. And I started recently Gopher Lab, where you will get a full from beginner if you don't know the Go language. So I have created slides uh, from basic, like everything from like basic. Uh, so I have creating this content from long time. So I have around currently 200 plus tutorial, and you can, if you want to contribute, you can just this is a git repo, mm, Collaboranix Docker lab. You can go and you can rise a PR. That's it from my side. So be be smart, like stay at home. So we'll fight this coronavirus. It's not it's not it's just small virus. Don't be panic. Stay at home. Thank you. You can follow me on, you can catch me on like on
You,
Twitter.
what's your,
Oh, yeah.
you can use yours right now.
I did.
Can you mute?
You did? Okay.
Thank you so much, Chandan. Any questions?
You turn off your mute your speakers.
Speakers.
Yeah, okay.
Oh, question from Syrian.
Yeah, tensor model building.
Hmm.
So why I am just why I when you
Please
use
mute yourself. Please stop
when you
mute.
use a Python, if you use a Python, there is no call like uh, channels or routine. There is no concurrency feature in Python. So I thought Go is pretty much good for TensorFlow as well. Uh, you can like you can use a Python also. Is depend on your choice what kind of application, what kind of language you are using to build a particular application. But if you use a Go language, I just want to show you that in Go language also you can do pretty much better thing of machine learning. Yeah, because in Python there is no channels and Go routine. You can use a Go feature to use run faster than Python. For model building, you can use a Python. So I took already a train model, but uh, you can use actually Go language also for building a model. There are libraries. You can search. There are a lot of libraries coming up now. Go community is creating a lot of you can go to go for you can go, there is a channel call for machine learning, Go for machine learning, um, where you will get a lot of libraries.
Any
So
other questions?
I didn't
Okay.
use for building a model in Go language. I took a already pre-trained model and I just done prediction.
Nice.
Yeah, anyone have question around like Docker, Go language, Kubernetes? You
Any
can
other
ask anything.
questions?
Yeah, any other question?
Think- Yeah, I think that's all the question. Let's take a let's all turn on our camera and take a picture. Because this is our first online meetup ever. Survival picture, guys. Shifu, can you come over here? Oh, actually, you can turn on that camera as well.
Nice, nice. Ooh, lots of people. Okay, cool. Okay. Picture.
Picture, guys.
Okay. Okay. Thank you.
Alright, sweet. Thanks for joining the meetup. See you around in the next meetup in a couple of months.
Yeah.
All right, see you around.
Thank you for coming.
Thanks for attending. Thanks for the talks. Yeah.
All right.
Right.
Thank you.
Thanks, guys.